Let's resume recording. So this is where we started, right? And last time, from last class, we did the body, and this time we're gonna start with the top part. So let's do this one first. All right. So this part is still very easy. You can see everything is based on the rectangular plate. So let's get the measurements and we can start. So apparently it should be 6 by 12. That way is because it's on top of the body. That body is 6 by 12, and this one is 6 by 12 by 1. So let's take it down, 6 by 12 by 1. And also the top rectangular block. So this is just a uniform groove for the shaft. So this will have a 1 inch diameter. So 1 inch groove. And this one is 1.5 by 2 by half. So 1.5 by 2 by half. And the location is apparently at the center and 3/4 from the edge. And total is 5 blocks. Okay. So with that, we can start. Always make new, make a new part. So from here, before you get started, always save. So save as to your designated location and with the part's name. You can name it part 1, part 2, part 3, like that, or you can name it by names. It's up to you. I'm not going to save it this time, but do make sure you save at the beginning. And let's draw the base plate. So very easy 6 by 12, and we extrude it to be 1 inch thick. All right, because 6 by 12 by 1. And once we have that, we go to the top surface and start making those the small blocks on the top. So from here, you'll see, even though it is referencing the center point, but is not actually being secured. So if you create a center line and just make this point with the center line, set them to coincide, and that should do it. And now we can set this to be 2 by 1.5 by half, and this should be half. And have this one to the edge. That's 0.75. Okay. Then you can extrude this by another 1.5. So from the preview, looks right. So we're happy. Then you can have this feature patterned along the X direction. I need to select this feature and have this one patterned. And this edge is along X direction, so it's good. And we need total of 5. And the spacing, we need to do a little bit of math here. So the center distance from the edge is 1 because it's 0.75 plus 0.25. So 12 minus 1 here, that gives 10. And there's 1, 2, 3, 4, 4 spacings. 10 divided by 10, 10 divided by 4, so 2.5. And here we go. We have a very basic configuration that's similar to what we're making here. And now we need to make the groove on the top and also the small holes. And let's take the measurement of the small hole, which is 1/2 inch in diameter. And the depth is 1/2 inch deep. All right, and apparently this hole needs to be at the center of the spot. Okay, so either start from this surface or the other surface. We can start drawing the circle so we can extrude cut it to form the groove. And this is the center line, a center point actually. So this one is 1. And extrude cut this all the way through. The spacing is 2.5, 10 divided by 4. So once we have the groove, we can work from this surface and have the hole generated. Still using a circle. And from here, there's no reference, right? But if we want to make it exactly to the center, we can always have center lines. It's never hurt to have too many center lines because those are construction lines. And starting from here, and have this as 0.25, which is a quarter. And extrude cut this down to 1/2 inch, right? 0.5. Click OK. Now we have one hole. Now we need to pattern it all the way. Pattern it into all different 10 surfaces. So we have 10 holes for securing down the top bracket. So still linear pattern. And this time, X direction goes first and Y direction goes second. Oh, sorry, Z direction goes second. The step with adding those parts again. Oh, you mean to place this block? Yeah. Actually, I can do that. Give me 1 second. Let me finish this. Set this as 2 because we have 2 rows of the holes, right? And reverse direction. So this is off. So we need to change this because the entire length right here from that edge to this edge is 2. 2 minus a quarter minus another quarter is 1.5. And there we have it. So actually, just let me finish this. Can I finish this part and then I'll show how to make this block? Yeah, thank you. So it doesn't, the recording won't look so weird, you know. And once we have that, we need to work on this surface and all the features, the holes and all that. And let's get the measurement. So we're from the biggest hole first. It has a counterbore. So 2 set of diameter. One is 1 inch and another one is 1/2 inch. And the counterbore depth is 1/2. So 1 inch diameter and 1/2 inch hole and 1/2 inch bore depth, right? And total of 6. And then this rectangular slot is 1/2 by 3. And since it's along this edge, so we don't take any other measurements from the edge. So it's 3 by 0.5 rectangular opening all the way through. And these small holes, they are in the same size. This is 0.38, so 3/8 of an inch. And just verify, yeah, it's the same. So 3 holes a set, total of 4 sets, and they're all 3/8 in diameter. And 2 has counterbore, and the counterbore diameter will be 1/4 and 1/4. And spacing is 0.5. And the center distance to the edge is 2. Okay, so 3/8 whole times 3 times 4, 12. And the counterbore how deep was it? A quarter deep. And what else? Oh, 0.5 spacing, right? And this is center distance 0.5, 0.5. Okay, they're all 0.5. So 0.5 spacing, 0.5 from edge. And let me copy and paste this to the chat. Okay, so let's jump back to this one and let's start making all the holes. So I have the big hole at this corner and also a concentric one for, well, let's not do that yet. I have this big hole as 1 inch. And this from the edge is, okay, didn't take that. Let's go back. Three quarters. And 3/4. So 3/4 for the big hole. Oh, I already query one right here. And from this edge as well, 3/4. Okay. And then we can extrude cut it to the board depth, which is 1/2 inch and 1/2 inch right here. Okay. So we have a very nice counterbore. And from this surface, we can start making the through hole. So if the center point doesn't show up, you just need to hop over the circle and that center point showed up. That's 0.5. Also extrude cut it all the way to the bottom. So through all. And here we have the through hole with the counterbore. And let's select these two features together and pattern it in both directions to have a total quantity of 6. So for this, we need to change it to 3. And this side, we need to is already 2. We just need to flip the direction. And the spacing for this one, will be 6 minus 3/4 minus another 3/4. So it's going to be 4.5. And from this direction, it will be 12 minus 3/4 minus another 3/4, which give us 10.5 and 2 spacing, so divided by 2. And here we go. We have the big holes. And now let's do the small holes in the center. And since we know they're lying on the center, we just need to create a center line right across and start making a set of a small hole. Okay, we have 3 holes and we can select them. Oh, we can dimension one of it first as 3/8. Also have this set as half. Nope, this is not what I wanted. Okay. There are plenty of ways of doing this, and I'm just showing you one of the way to do it. So if you want to be creative, and you can still do it right by so many different other ways. So once we define one of the circle diameter, we select all 3 together and set them equal. So they will have the same. So you can see the equal sign here, that little blue. All right. So from here, we can pattern this. Let's do extrude cut first. Same through roll or app to surface. This is up to you. So we have a set of 3 holes. And then let's pattern this linearly. So this time it's just going to be a single direction and total of 4 sets. And the spacing, it will be the same as the supporting block, 2.5. And now, if you guys can see, there's a problem. So we create the 3x hole, but we didn't create any of the counterbore. So they're already through holes. And we need to do is to make a material. So from the cross-sectional view, you can see those are uniform diameter. So we need to make a material from the middle to form the counterbore. Or initially we can change a different method to do this, but it's totally up to you. Because at this point, the objective is just to have you to make the correct model. So what kind of practice you use at this point is not necessarily important. So you can work from the bottom, since the counterbore going to start from the bottom, or you can create a plane right at the counterbore depth and work from there to the bottom. It's totally up to you. So we can create a plane from the top surface and get it down to the counterbore depth, which is 1/4. We need to flip direction. Yep, so the counterbore will be starting from here. And let's select this plane and start sketching. Wait, why the, give me 1 second. The holes are not at the center. So exit that first. So that is the center line. All right. That's kind of bad. So the whole thing is not at the center. Wait, this is. Okay. So this point was off center. All right. Now that should do it. Yep. Sorry, guys. Yeah, if you can see, if you make some mistake at the first step, you need to spend more time and to dig through and fix the issue. All right, so now we can select this plane and start sketching. All right, so there is no reference. Same thing, just hop it over and make this counterbore. And also you need to make another circle, same thing like that, because right now we're creating material. So you need to have an enclosed area. Right? And same thing, do it here. Okay, so pretty much we just created two rings. And now we can extrude these two rings. And we don't want the in this direction. We want to switch to all the way to the bottom. And we can say app to surface and select the bottom surface. So from the preview, you can see it's starting from here and ends right there. And there we have the counterbore. And by patterning this counterbore along the X direction, and it automatically referenced for us. And here we complete the set, the 4 sets of small holes. Any question? How did I do the pattern? Or how did I do the counterbore? So in the pattern, the feature you selected is the counterbore which is made, right? By extruding two rings. And from there, you select this a direction, which is the X direction. This edge is along X direction. Select this edge or that edge or center line, doesn't matter. And then the spacing and total of 4 sets. And that's how you did it. And from there, pretty much, the rectangular opening. So remember the rectangular opening should be on the right. So let's zoom in by here and start sketch. Always draw a center line so that, you know, you don't have to dimension it from top and bottom edges. And start with the center rectangle. And when you hover over right here, it sort of automatically select the reference. So make it along the edge. And it's 3 by half, right? So this should be half. And the total length is 3. There we have it. And we extrude cut it. You can through all or up to surface. It's up to you. So pretty much this completes the top feature. Right? So from the top, it will look identical. And now we need to generate the side port. So to pay attention, there are 4 ports per side, left, the top side and bottom side, or left side, right side, or whatever we call it. And let's take some measurement. So the diameter will be 1/4. So side ports, 1/4 inch diameter. And if we create a cross-sectional view, you'll see the side port go directly to the hole on the left and the right and leave the center hole alone. So based on this orientation, which the rectangular opening on the right side, the bottom port should go directly to the first hole, and the other side port will go to the third hole, and 4 ports per side with 1/4 inch diameter. And let's just verify. So that's 10, that's 1/2 inch to the edge. And I'll say, okay, so all the holes are perfectly at the center. So with that information, let's jump back to here. So pretty much we need to start making holes right here. There are plenty of ways to do that. Like I said, the best practice is to set up a plane right here and have your hole exactly centered at the plane, or you can do the calculation where the center distance to the edge and, you know, start from there. And still make center line because it's at the center, right? But it doesn't have to be whole across. You can always drag this. So I have this hole starting right here and define it as 1/4. And now a left is that distance to here. So if you still remember, this is 3/4 and this is half and this is half. So 3/4 plus half plus half. Okay. And this hole go directly into here, but no more. It doesn't go through it. Therefore, we can extrude cut this, go all the way in, but have to surface. And the plane we're gonna select will be the front plane, because the front plane is exactly in the middle. And let me get rid of this plane. Right. So before we proceed, let's double check. Okay, exactly what we wanted, right? We just need to pattern it 4 times and then do the opposite side and pattern another 4 times. All right, by selecting this and still linear pattern, go along X direction, and it automatically already set it up for you because it's the same spacing and same set number. This, you click OK, and if you still worries, you can always check. Oh, this is exactly what we wanted. Then you can work from this side, and this side is no longer the first hole. Well, this side is the first hole, so that side is the third hole, but if we rotated this orientation, it will still be the first hole. So pretty much just repeating what we just did. Have a circle right here and set up as 0.25. And have this 0.75 plus 0.5 plus 0.5. And then although we cut it, select app to surface and pick your front plane as the target surface. And here we go, and pattern this. Four times. If you like to check, go cross-sectional, select top plane, reverse direction. And here we go. All right, so that completes the top and side feature for this part, and all we left is whatever at the bottom. So this is quite simple. Just take the diameter, which is 2 inches. Bottom 2 inch diameter, and the depth is 1/4. Okay, and let me copy and paste this into the chat. And you can tell right here, the center, this big circle is concentric with the center one. And we did that on purpose. So you can simply just flip it and start making the circle that is concentric with the bigger hole at the bottom. I set it up 2 inches. And cut it in for 1/4. So at the end, we patterned it still along the X direction 4 times. That's already there for us. So super straightforward. And I hope you guys can practice maybe right after the class, so you have the fresh memory, because this has a lot of repetitive steps. That way you can memorize it like, for a longer time. Okay, any question about this part before I closed it? Oh, to show how to make this, right? So we can simply drag this blue bar, if you guys still remember what that blue bar does. So now it gave us this, and we don't want it. Drag it one more item, one more feature up. So now just left us the plate. So first thing, since it's on the center line, right? So I'll just make a center line as your reference and use the rectangular feature. And here, and if I still remember this correctly, is oops, is 2/2. And have this to the edge as 3/4, right? And then extrude it by 1.5. So this is how you make one of this. And then you pattern it 5 times. Yeah, pattern it 5 times with a spacing of 2.5. Okay. No problem. Any other questions before I exit this part? Okay, it looked pretty straightforward, right? I kind of feel like you guys can, after just one time practice, you just can totally memorize everything and just redo it again, right? Yeah, pretty much all we use is rectangle, circle, extrude, cut, and nothing else. Okay, if there's no question, I'm gonna, okay. One final advice here, always save it before you're, after you complete or after you think you complete, always save it. So pretty much just Control S it. If you already save as in a customized name at the beginning, that this window won't pop up. You just need to click Control+S, just like other documents. All right, so always remember to save. Otherwise, you have to spend time to do it again because there's pretty much no way to recover it by your SolidWorks. If you work off a like company's cloud system, like a Vault or something, like it can save from time by time, but at this moment, like you're not able to retrieve it back if you didn't save and something happened. All right, so that completes this part. And then let's start doing this little bracket because it makes into this rectangular block. So this is quite simple. It looked like a magnet. Like it's a the top bracket. So you might wonder what forms this shape, right? And I'm gonna get out this. Nope. Okay. This. Yeah, I don't want a shadow. All right. So pretty much is the chamfer and fillet doing all the job to smooth the corner. And normally this is not the way it should do it, but anyway, this is just a class, right? So pretty much we need to generate something like this first, and then apply the chamfer and fillet, so it's gonna have a very smooth edge. So let's take the measurement right here. And oh, and totally you can tell it's just a rectangular block with the center groove and with 2 holes with counterbores and through holes. Very easy, straightforward. That's 1 inch by 2 inch by half. So you have 1 times 2 times 0.5. And the center groove in diameter of 1 inch. So 1 inch diameter center groove. And then we have 2 holes. So 3/8 diameter and 1/4 diameter. And the board depth, the counter board depth is half. The location of this hole is a quarter, center distance a quarter, and this a quarter from edge. Okay. So whoever is confident enough, you can start working by generating this very simple geometry by the dimensions in chat. And create new part. First thing first, save as, right? I'm not gonna save it, but you should save it. After that, we can start sketch. So this time, do select the point of origin. Don't make the mistake from last time. And set this as 2. And this will be 1. And the thickness by extrude is half. Okay. There we have it, the rectangular block. And from this surface, let's do a center groove. So find the bottom center point and do a circle and have the circle set as 1, if I remember correctly. 1 inch diameter center groove, right? And cut it all the way through or up to surface. And there we go. We have center groove. And now let's worry about the 2 holes on the top. And still, you can either use this or create center line. Yeah, I feel like I keep repeating myself about center line. And have this at 3/8. And make this a quarter from the edge. And then we can cut it to the counterboard's depth, which is ½ inch. So it's already ½ inch blind. And here we go. We cut it in, and from this inner surface, let's do the through hole. By a quarter. Extra cut it all the way through. And here we have one side of the hole, and do make sure to select both feature because we're going to pattern it all the way across. So that's the direction we're selecting. This time we just need 2. And the spacing, let's do a simple math. This is 2 inch and minus a quarter, minus another quarter. So 2 minus quarter minus a quarter. And here we go, we have it. So the final step is to apply the chamfer and the fillet. And the chamfer gives the dimension is ½ inch by 45 degrees, which is pretty standard. And the fillet gives a ½ inch radius. Okay, let me repost this into the chat. With this information, we can come back and start working. So chamfer goes first. Why is that? Because we only have one edge at the corner. If we go fillet, it'll be round and no more edge. We cannot apply the chamfer anymore. So chamfer goes first. And select these 2 edges. And come here is 0.5 inch by 45 degrees. Okay. And click yes. And now we have two more edges from each side. Now we can go fill it by selecting all 4 edges. And set up the magnitude to 0.5 in radius. So do pay attention, this is always in radius. So here we have it. And at this point, you should save it. Okay, always save your work. And then let's compare. Exactly the same. Okay, any questions? Okay, yeah, this part is even easier, right? Okay, so I purposely left the 2 shaft because next week we're gonna go through nothing but these 2 shafts. So let's find this piston head from internal and start working on this one first. So this piston head has a little bit internal features. So you need to pay extra attention. First thing, we still need to form the cylindrical, the cylinder, and then cut the grooves, make the through hole. This is a through hole. That's gonna have the link to the stroke. After make the through hole, we can generate whatever happens internally, and then apply all the fillet, like all the surface, those round because that fillet. So if we suppress the fillet, it will look all the sharp edges. And this one is okay. All right, so let's start by, I'll say the other side. You can change your reference plane by here. If you change it to the right plane, it'll look like this. Okay, so first thing first, what is the diameter? So radius is 1, diameter is 2. And how tall this thing? Center distance 2. So for the piston will be 2-inch diameter times 2 height. And the through hole is 1-inch diameter. Since is pretty much at the center, so we just need to get 1 distance. Oh. Center distance is 0.63. Yep, that is the center distance. So probably 0.625 from the edge. That's 5/8 from bottom edge. And now it has 1, 2, 3 grooves and one all the way through the bottom. So the groove should have a radius of 0.94. So it's 1.88 diameter. So times 3. And the width is center distance is 1/8. And the first groove is a quarter from top. And just to make sure the spacing is the same as the width, yep, is 1/8. Okay. So 1, 2, 3. After 3 gives another 1/8, and we have one. I'll say this is the body. So that's all the external features, and let's start making it. So go to new part. And let's make the cylinder with two-inch diameter and extrude it to another 2 inches. So this is our body. And with this body, we can start, let's see this, okay. So with this body, we can start making the through hole. Select the front plane or the right plane, either one. Start making a circle. Before that, always center line. This is kind of, yeah, here. Make that through hole, and the hole diameter should be 1 inch and 5/8 from the bottom. Is it really one inch? It seems too big. It should be half. Probably I took it wrong. And this time you notice, because we select the front plane, is the sketch is inside of the body. So once we extrude cut it, we need to select through all in both direction. That way, it's gonna give us a through hole. Otherwise, you have to cut it again. Let's just go back to verify the hole size. Yeah, diameter is 0.5. I don't know why I'm saying this is 1 inch. All right. So let's make a cross section. So that would be better for us to make the groove. Once we make the cross section, we know we need to make the groove on the at the center and revolve cut it 3 or 4 times so that we're gonna have the groove. And notice this surface cannot be selected because we're in a view. It's not the actual surface of the subject. So in terms of to sketch on the surface, we need to make a plane, and guess what? We already have a plane because the front plane lies exactly on this cross section. Because we made the cross section based off this plane. So we can use the front plane, and now we start sketch that little rectangles. And if we want to, I mean, we definitely want to along this edge, right? But this edge is not popping up in any reference. So we make any rectangle, you see this edge is not along, is not laying on the edge. Therefore, even though maybe you think you are, maybe you think you are like pretty close, but sometimes it's not. So when you perform the extrude cut, if this edge is not exceeding the edge, you will just cut internally. So you'll never see the edge from outside. Therefore, there are a couple of ways to do it. The first way, you can always drag it over, like make extra, like just overcut it, because this side is cutting air, right? We don't care about how much it's cutting air. Or you want to do it legit, you can convert entity and try to select this edge. Yeah, I don't know why it doesn't select. I spent quite a bit of time on Tuesday's class. I don't want 3D sketch. Yeah, this is very frustrating. I don't quite remember how I managed to make this on Tuesday's class, but let's just not waste time and go the different route. There's always more than one way to make things right, right? Select the front plane, and let's draw the rectangle. Just overcut it. All right. And then we also need a center line because we need the reference to make the groove since it will be revolving, right? So this side will be the radius that we measured is 0.94. And this side will be a 1/4 inch, right? And the width will be 1/8. Okay, so it's still fully defined geometry, and we have that. We select the rectangle. We can pattern it. Right, this is the part also didn't work the last time. Hey. All right, guess we're just gonna keep making rectangles because we need, I don't want to create any relationship, so no reference are allowed. And make all that lines equal. Wait, not parallel. And define this again. So 1/8 and another 1/8. And we need to make a bigger one from the bottom. Right. And if you like, you can also make this line equal to each other. All right, that way we have 4 enclosed contours, and we can revolve cut it. So it automatically select the center axis for us, and there we have it. The only thing left will be stuff from internally. Let's get rid of this cross section. So from here, we need to go back and measure the inside diameter is. So ID is, inner diameter is 1.62. And also this is some backed up material for this hole, just as reinforcement. The width is 3/4. And this, how thick it is, there is another way to measure that, is the center, which is 0.88. And without that, also, oh yeah, the fillet radius is 0.06, so it's 1/16. Okay. And every single edge. Okay. Let's jump back and let me post this to the chat. So first thing, make a concentric hole. Have this matching the ID, which is 1.62. Oh, I forgot to measure the thickness. I mean how deep this cut will be is 1.81. All right. And now we can go back and finish the extrude cut. So you go in all the way 1.81. That's about right. Now we have the opening. We just need to fill it up with the inner features. So remember, the hole is top and bottom, not left and right. So we need to add material here, so they're pretty symmetric. And let's do some center lines, if you don't mind. And center rectangle, that will be on this. Right. So one thing about this is we either can convert entity for this edge and make it make a perfect match, or we can just do a rectangle, like go inside of the material, because once you extrude it, it will not double generate material, so your mass property will still be valid. So this is one way to save time, but if you want to do perfectly, that's fine either. So have this as 0.44 because the other side we'll have another 0.44 to make up the 0.88. And this will be 3/4. And see, this one is off the center. That way, that's why we need to select the point and the line and make them coincide. And then if you like to define that, it's okay. If not, just leave it hanging. Make sure it doesn't go outside of the go outside of the wall, so it doesn't give you a spike. And there you can select these 4. Use a mirror about this center point, the center line, and there you have it. So if you measure there to here, is 0.88, and this is on the bottom surface. Just make sure those edges are, those corners are not extruding the outer wall. And then you can extrude to add that backed up material for the hole, reverse, and don't do exact value, because sometimes it'll leave a very small gap if you didn't input it correctly. And you know if it's going to a surface, so just always do up to surface. So later on, when you guys are in touch with FEA, finite element analysis, you guys will learn that don't always make perfect matching, because sometimes CAD software are not that smart. They will leave a very small gap, and that will cause like a really bad result for your analysis. So you always want to go into the material and make sure they're 100% interference. So just a little bit tip. There's nothing about this class though, but you guys will learn that later on. And you see the holes are blocked. Why is that? It's because in the feature tree, the background material added after the hole is made. So when this model load up, they're going to read the first feature, the second feature, and third, and all that, and then they read the backup material, and that's why it's blocking the holes. So the solution is either drag this whole feature down, then you'll have through hole, or you can move this up. Depends on the importance of the feature. If the feature is less important than the other one, move this one first. All right, always leave the important feature alone and modify or move the non-important ones. And from there, we can apply the fillet as the last step, which is 1/16. And pretty much we need to select all the edges, and you can select surface as well. Oops. That's what they did initially, and gave you an identical part as what we're trying to make. So for the screenshot, remember the second project is a report, so it requires screenshot of every part and assembly or even sub-assembly they're making. For this kind of part, it has external feature and also internal feature. I want you to display it either like orientation like this, take a screenshot so I can see the internal and also external, or take a shot like that, take a shot like that, and in the caption explain that's the top, that's view from top, and this is the view from bottom. Okay. This is quite important because it's about grading, so I want to make sure everybody understand that. Please respond in chat if you hear me and understand what I'm asking. And we have 15 people. If you guys are all awake, I'm expecting to see 15 yes. Okay, so these, oh, and don't forget to save it. Always save at the end or save when you think you're completed. Always save it. All right, guys, these are these are all I want to cover for today. We went through another 3 parts. So next week, we're gonna go these 2 shafts. It'll take a little bit of time because those shafts are made by extrude little by little. So that'll definitely take some time. And if we have more time, we're gonna go through some the small features, like for example, this one, the spring, it just helical sweep. And other than that, they're all very simple. It just need a process to make them together. So if you have no question and all clear, you are free to go. I'm gonna upload the video recording tonight on YouTube and post a link on Canvas. If you have any question, now is a good time to speak up or let me know in chat. Thank you guys. Thank you for coming. And please make sure start your first project, please. All right. I don't want to see somebody saying they wait till last minute and don't have enough time to complete it, because we do have a due day, which is the last day of the class. I believe it's September 5th, right? Sorry, December 5th. So make sure you start early, and if you have extra time, start making the parts per recording. That way, if you have any question, you can ask next time in class, and I'll just show it one more time for I'll just show it again to you. Don't wait till the last week.
Thank you, Professor.